proceed. We
Yes, ma'am.
now proceed to the next session, 13 of the FDP. It is our honor to welcome Dr. Shu Shangshu, Associate Professor and Master Supervisor at the School of Energy and Power Engineering, Jiangsu University of Science and Technology. His research areas include the development of low-carbon engines using methanol and natural gas, improvement of combustion, performance in micro-injection ignition engines, and analysis of exhaust gas reaction pathways. He also works on fuel cell channel design, thermal management, and marine fuel cell applications. With over 30 publications in reputed journals and participation in 17 national and international conferences, his expertise brings strong academic and practical value to today's session. We are confident that the session will be highly informative and enriching for all participants. Welcome, sir.
Okay, I can start it. Hello? Can you hear
Yes,
me?
sir. Yes, sir.
Yeah. Can I start my presentation?
Yes, sir.
Okay. Okay, nice to meet you.
Thank you, sir.
Okay, thank you very much for giving me this reason to make the presentation. My presentation title is Application of the Multi-Field Hybrid Power System in Ships. I come from the Energy and Power College of the Jiangsu University of Science and Technology. My name is Changchun Xu. Do you know my research topic is ICE? But this application of the multi-field hybrid power system in ship is include the ICE and the fuel cell together. So we will start the presentation. So this is the contents. We will to follow the three parts. We are to introduce my research topic or the ICE in the future, how to make the process, how to make the research. We will to introduce from these three parts. So the first one is a background over value, and the second one is the developments trend of the marine power system, and the third one is the conclusions. So the first one is the background overview. So we know, wait a moment. So we will maybe in the world we have to make the traffic or the plan or the chain will be make some travel. So in the 2022 years, the total global trade value maybe has, sorry, I can't see. Value reached 32 trillion US dollars, but in this one we have 80% was the transported by the sea. By the sea is the ocean going vessels. So the global maritime is shipping volume service as the barometers of the world economy. Trade is globalization. So we can do this. But the sea transportation has the 80%, but the left areas is includes the traffic or the plane at 20%. So we know how to make the ICE research. I think we make the ICE research how to make the ocean going research ICE research. So this is my research topic. Okay, so I know we will know the hybrid power system, but what is this? The power system is that incorporates multiple energy source, not include the cells, but can be provide the power for the mean proportions of the cells. For example, is we not to use the engine. I just use the maybe fuel cell to give the power for the ocean-going vessels. So this is, I think, we can do complex with the diesel and the fuel cell together. Maybe I think this is a hybrid power system. So in the hybrid power system, so we have to include the four parts, which first the second one is an engine storage system, and the second one is the fuel cell system, and the third one maybe is gas dual fuel main engine or gas dual fuel generator set. Why have two? But I think in the hybrid system, so this is one part, this is one part. So this is together one part. So we have to connect with the main engines and generators sets together. Sometimes we will use the motor make the power, and sometimes we have used the main engine with the power, use the power. So this is a hybrid power system. So we will to, but the hybrid power system is not traditional energy source such as the four parts, such as energy storage device, and the fuel cell system, and the gas dual fuel energies and gas dual generators. So for we can to see these pictures. We have two parts. The first one. So the first one is this part we will just use the auxiliary power is fuel cell or provided electricity. So the big one, maybe we think this is the engine, the low speed engine. So may power source directly drive over for the propeller. So we think the hybrid power system is one or more working models. So the models how to set up maybe is a series hybrid power system or uh, par parallel hybrid power system. So this is a one or more working model to set up for the hybrid power system. So this is can be formed through different energy mixing the method. Okay, so the next one, the shape hybrid power system. We know is one or two more models to set up for the hybrid system. So the system just use two or more power source as a proportion power. So is include the main engine and the electric motor together to give the shape power. So the electric motor is driven by the generator. Yes, so I told you we include the four parts: storage, fuel cell, and engine. And the fourth one is the generator cells. So driven by generator cells, fuel cells, or the energy storage device. So we can to tell this is a electro motor. So the fuel cell or the energy storage device is use the battery or the super capacitor. So operations model of the hybrid system, we will to set power outputs and the power inputs, and the third one is the power return. Why to set? We will set the third parts. So first one is the power output. We can to think is engine or the battery give the shape power, and the power input is just the generator cells is from the engine get the power into the generator cells and give the shapes power. At the power return, maybe uh, we will to the shape we will to going or the operating with the high speeds. So the energy how to go? It's just return to the battery or the supercapacitor to make the energy to setting collecting. So it's the power return. Okay, so we set the third parts, power output, power input, or the power returned. Okay, okay. As how purpose are the same design electrical proportion. So sometimes it's same, sometimes it's different. We how to compare this, we have to know what is the hybrid proportion. So this is a ships mainly use the traditional field-powered engine and the power source generated by the rechargeable batteries or other means for the alternating proportion. This is a hybrid proportion, and hybrid proportion refers to ship that has a power supply of a mainstream propulsion system or another additional or some main in the form of the rechargeable batteries together. So we can to call this one is as a hybrid propulsion. So the next one is the diesel electric propulsion. Sometimes we just call this system as a hybrid system, but it's different. It's different. This one, maybe we just use the engine, give some give some others generator cells power, and just use the electric as a power. But this one is we also use the diesel. We can also use the electric. So together, so this is the diesel electric proportion. Okay. Okay. Hybrid portion has some involved. It's just how to charge the wirelessly and how to arrange the batteries and the emissions reduction advantages of the hybrid power system. So as the next step is just include the two parts. The two parts is plug-in hybrid vehicle and conventional hybrid powered vehicle. So this is just only to use the electric. But we have the diesel engine, but the diesel engine not give the ship power. It just give generator sets the power. Use conventional inverter to the electric and use the electric. But another's as conventional hybrid power setting is together use the diesel and use the electric. So we have some advantages. One is economy and safety and environment. Okay, so shaped hybrid system. What is? It's just not fully electric. Instead, they can exist with traditional energy, similar to the electric vehicles. But this is a mechanism required for the switch between the two power sources. So the two power sources can be exchanged. Sometimes we can use electric, sometimes we can use the diesel engine. So for the depending for the both power source, we can to need this. Which one we will need? Which one we will need? So the first picture is a plug-in hybrid vehicle, and the second one is a traditional hybrid powered shape. So follow the advantage of the future direction of the hybrid powered shape, we have to consider the fuel efficiency and reduce the emissions. Why? Because we use engine, the engine use the diesel or the gasoline. So we have to think about that. Sometimes the fuel cell maybe has the emissions. So we just use the hybrid as consider the fuel efficiency and emissions reduction. Okay, others is propulsive efficiency and flexibility and noise aberration. We know we will use electric vehicles that is a no noise, no vibration, no vibration. So this is the uh, advantages. So compared with the traditional pure diesel propulsion is fuel consumption. Consumption is reduced by 15 or 20%. And this is attributes as a fully electric operation model in the low power situations. Because use the low power situations is the absorption of the peak loss. Use the peak loss, we just observe for the electric. So the fuel consumption is reduced by 15 or 20%. And compared with the traditional per diesel propulsion, is the emissions reduction and the carbon ignition is 20%. to 30%. So the effective the fuel consumptions is equal to reduction in the use of carbon and other house emissions. So we use the hybrid is just the important point is the fuel emissions and reduce the emission. Okay. Okay. So what problems have affected the hybrids process? So I think the first one is the no power connection because the battery has run out of charge. So we connect with the engine together with the hybrid power, use the engine, make the connect with the motor, use the engine power to charge the motor, you to give the shape power. And during the low speed driving, the engines performs poorly and only operates at the medium or the higher speed. So this is when at the medium and the higher speeds, also charging the battery. And the engine we need to be the stored in is used to push the shape at a very low speed. Why? Because it enhances the efficiency of the engine. So I think this is a problem has affected its process. So the first is the source of the engine. The engine, which parts can give us the engine, and the conventional fields, which field we will be used. And winter to the electric energy. So this is maybe this is the engine, this is the motor. So because according to the effective engine, we will use the electrochemical energy for the fair share for the share. So in the process, the losses caused the parallel hybrid power system would amount to 22%. So sometimes uh, we will to increase the weight of the shape, reduce the speed of the shape. So because this the fuel cells or the hybrid power system not give the more enough power to can make the ocean going vessels going. So it is necessary to reduce the power demand of the vessel when it is traveling at the whole speeds and to modify the care structure of the vessel. Okay, because this reason can make this. So the next one is the lifespan. The lifespan is the weakness for the hybrid power because the hybrid power maybe the shape is not too big, so the hybrid power maybe not give the vessels has no enough power to make the is running. So the lifespan, the hybrid power, the lifespan is a weakness, and to overcome it, the battery needed to be increased and the lifetime extends, and the frequency of the hybrid power enhance the service life. At the same the lifespan and the energy storage system is important for the hybrid power. So how to make the hybrid power the thermal management? We just have to check up the temperature rise of the battery, and the engine concentration, and risk of the uh, collision, and risk the battery management system fire and uh, condition with the ship management system, and make the measurements of the maintenance. So just is one, two, three, maybe seven seven parts we can to enhance the hybrid power, the thermal management. Okay, this is why what problems had have affected this process. So we have to make the various powers comparison. We just follow the table. We compare the low speed DDR engine, medium speed DDR engine, and high speed DDR engine, and high power gas turbine engine, and low power gas turbine engine, micro fuel cell, solar engine, and wind engine. So we how to find it? It's we just compare the thermal efficiency and the fair and the load relations. We can to find the low speed diesel engine the thermal efficiency is 53 to 55%, and the fares is the best, and the load variations is the best. But this I think is an error. I make the translation, but I think this is the best, not good. I think it is best. So follow the history. We have to choose which one is low fuel consumption and the minimum total life cycle cost, and the high efficiency and wide operating conditions. So follow the table the comparison. We just find the low speed diesel engine is best. To show us is the engine ICE still excited uh, for the service for the world. So I think the ICE is best. I think it is best. So this is we can to compare continue to the shape power form is reciprocating international combustion engine like diesel dual fuels. Another one is the batteries gas turbine and steam turbines like this. So we can find only 1% is include the batteries, gas turbine and steam turbines, and the other 99% is use the ICE as the internal combustion engine. So I think the reciprocating international combustion engine is the main power source for the ocean-going and inland waterways we have. So for this comparison, we can to find 99% of the world's ships are powered by the internal uh, internal combustions engines. So I think this is a main power source is ICE. Okay. Okay. So this is ICE in the main power source of the for ocean going and inland waterways as the typical engine. No. So this is a high speed engine. It's a fuel consumption is 2 211, and the thermal efficiency is 40%. And the medium speed engine, maybe this is the fuel consumption is 188, and the thermal efficiency is 45%. And the low speed engine, we just compare with the low speed engine. So the fuel consumption is 165, and the thermal effectivity is the 51%. So it's the high, and the fuel consumption is low, is the lowest. Well, compare the three speed engine. So there's a difference. Okay, the second one is the development trend of the marine power systems. So we first one we have to talk about the regulations at the drive. So for the first is the uh 2008 years and the 2050 years. So we just use the B30U and the second level, third level, and the fourth level. So the second level is 2030 years is a carbon emission. Carbon emission maybe has directed by 20 or 30%, and to the 2040 years, the carbon emissions we have to decrease by 70 to 80 certains, and go to the 2050 years, we have to make the zero emissions of greenhouse gases like is the carbon dioxide. So we follow the short term and mid phase and the long term. So the first as the short term is research on the alternative, the low carbon and zero carbon fuels like anomia and the methyl and uh, hydrogen. And metaphase is application for of the low carbon fuels, and how to use this like the methanol and LNG and the anemia and the hydrogen. So the long term is we have to uh, make the zero carbon fuel application to propose new or the innovative mechanism for the reduced emissions. So this is the time shaft, the time shaft. So to follow the regulations of the drive. Okay, the first we know we just the first one is the energy storage. So energy have to storage. What is the energy? Energy is the development and the transformation. We have two main transition. So the first, fossil fuel, and to the renewable fuel. And the third one is complex fuel, to low carbon fuel and carbon-free fuel. So this is the liquid. So from this is solid and liquid and gas. So the gas is include follow the fields shafts. We include the biodiesel, green methanol, and other green fuels, and green ammonia, and green hydrogen. So include this one. So which one is best? We have to make some experiment or the research to make us to make the uh, which one is best way to think. Okay. And the second one is expand the scope of the research on the shape power, like fuel engine and innovations in the post-processing system. So for the engine, we just include three parts. The first one is fuel, and the second one is the engine, and the third one is the post-engine research, is the will-to-wake and concepts. So the first one is the preparation before entering the engine, like green fuel for storage and the transportation and the selection of the new energy forms and development of the trends. And the second one is the research on the engine it lives, it serves, like the green fuel application, traditional thermal efficiency improvements, and clean combustion. And in the last is the uh, pollutants treatment system, engine recovery system, and the carbon capture system. I think the third one is important in the future. I think this is in the future. This is the research points at the best is the best points. So this is for the post-engine research. And the mineral power outlook is this is just come from the Clarkson's predictions of fuel structure for the new ships. So we can to follow the lines we can to find in the 2050 years, uh, zero carbon fuels will be uh, has accounted for the 79% of the total by the 2050. So this line, what this is the zero carbon, and the energy fuels is maybe to the 2050 years is the peak shares of the 21%, and 2030 years is the high is the 17%. So in the last is the zero. What this is the conventional fuel like diesel, gasoline like this. So we will be dropped to 30 percent by 2030 years, and completely replaced by 2050 years. Will be not used. So this is from the Clarkson's prediction give us the structure of the new shapes about the fields. Okay, so according to this one, according to the DNEG prediction, by 2050 years, 2000, we can to find 2050 years, it's just bi-methanol or the e-methanol will be used, and you can do the according to this one is ammonia will be replace the fossil fuels like the steel and gasoline. So the use of the ammonia fuels and the methanol fuels in the closed ships will be account for more than half. For more than half, like this is 81%. So will be in the future will be more high for the uh, global shapes for the fields. So according to the field, how to use this, how to, because in the shape we just make the storage. So first one is the production, storage, and the transposition of the green field. So this is important. But for the liquid like the methanol and ammonia, it's easy to make the storage. But the problem is just hydrogen. Hydrogen. How to make the storage? This is a program. This is a problem. So we have to find some method to serve it. So except for a few products and technologies such as the high George storage, high pressure pumps, and materials corrosion. And about the materials corrosion is according to the methanol or the uh, ammonia. According to the hydrogen storage is just for the how to solve the hydrogen because in the elements the hydrogen maybe in the air has about 2%. We will like the explosion like a bomb. So has some explosion happens. So this is a problem. So this is a very important as a hydrogen storage is important and in the future has a more high research points. This is important. Okay, the second one is the engine. This is the last one is fuel. This one is the engine. How to make the engine, which one? So the engine, dual fuel low speed engine will be widely applied. Why? Because high fuel efficiency and has a high thermal friction efficiency and low fuel consumption. So the market share of the engine low speed engine will be exceed 41%. So for the carbon fuels such as uh, ammonia fuels and depend for the low speed extend for reach like this is 11 million horsepower by 2050 years. According to the 35 for the total global demand for the low speed engine. So in the future, which part is the research main points is low speed engine. Low speed engine, how which energy will be used, which fuel will be used is ammonia or the methanol or the hydrogen. Hydrogen is has a big problem is how to make the storage. How to make the storage. This is the problem. Okay, we have to compare the methanol and ammonia and hydrogen. So, methanol production, the global production of the methanol has approximated at 170 million tons in the 2021, and in China just has uh, 973 million tons. So why to use the methanol? It has some uh, advantage. It reduce the carbon dioxide emissions by 10%, 10% because we just reduce this. So another one is ammonia. Ammonia for the is uh 2023. We just make the production is 240 million tons, and in China is has 61 million tons. So this is advantage. What is the advantage for the ammonia? It reduce the carbon dioxide emissions by up to 100%, but it has a big problem is healthy healthy risks. So we will to make the research, we have to uh, uh, pay attention to the health. Okay, another one is a hydrogen. Hydrogen is has no the carbon dioxide emissions because hydrogen it just make the calculation. It just produce the water, produce the water. So for the 2023 in the world has the 95 to 95 million tons can be produced because this is has the high technology to make this. So it's very in the future, maybe after the methanol and ammonia, after that, hydrogen can be make the research for the power for the power. Okay, so so according to this, we just don't know in the future is a low speed engine, and the fuel is methanol and ammonia and hydrogen will be focused on to make the research. So in this time, what company has done it. So the first one is a man company. So the company has made the research about the LNG, methanol, and LPG. So the methanol fueled engine has been included in the operation, and the ammonia fueled engine maybe uh, has completed as 2024 years by the company the DLGI or the auto low pressure GA in the parallel. So it just together uh, to make the ammonia the engines complete. So we can to follow the time shafts. So we can to find the enemy engine project started it from the 2020, maybe 2024, 23 together. So it's completed is from the main company. And this company is just for the methanol, such as for the methanol, and is maybe hydrogen fuel engines will be completed from the will be 2050, 2025 years will be completed in order to make the verifications how to use it. So this company will be complete the low carbon and the zero carbon fuel technology solution. So we can to compare this. What this company is according to the energy and ammonia and methanol and hydrogen. So according to the operations rate with the same field volume and efficiencies, we just to find we just use the hydrogen maybe 22% equal to the 100%. 100%. So we just use the small volume of the hydrogen. We can get the same power the 100% TTL research. So this is very important. It's a good point of the research in the future. According to these three films and another country maybe Japan. Japan has a Georgian power engine in the Japan research that has gas measure like Kawasaki and Yamaha and like the Japanese engine. And from the South Korean South Korea is make the cooperation with the MAN company is of the ammonia fueled powered ship that gets carried out. So it's according to the ammonia fueled low speed engines. So from this comparison, we find in the future ammonia and methanol or the hydrogen low speed engine has a focus on for the research, has a good point for the research. So according to the picture, this picture is from uh, the Japan. So we can to find the first electric is a small ports and hotspot use the electric for as a power to give the vessels. And for the inland waters, it use the hydrogen field because with the high speed vessels, so we just use the inland waters. And in the ocean, going vessels, we just use the combustion, like the engine as the power. the engine power has the power to give enough power for the running. So I think this one is one part. Another is methanol, maybe in the future hydrogen for the combustion for the vehicle engine for using. Okay. So it's an engine compares the company and countries which part have has the important research points. So the next one is the engine itself. How to make the engine? How to make? See, we have to make the features enhance the engines the thermal efficiency like 57 to 60 percent because now for the vehicles engine maybe is up to 48% is the highest. So how to follow the IMO's term tier 3 rules or the 4 rules and make the detailed methane and methanol, ammonia, and the hydrogen can be used area like the fuel flexibility. Okay. Okay. The next one is engine rear ends. It's just we have to make the engine like the post research have to application to any vessel, and no alternative fuels are required. But the weakness the weakness was is large in size and high in cost, currently unable to achieve zero carbon efficiency. So why to make the poster research, engine poster research? So okay, because include among the emissions has some uh, measure the leakage and the variance and emissions and the carbon capture. So the first time I told you the carbon capture is more important research point in the future. Why? Because we have to use parts to make the methanol and the ammonia's production. Uh, make the carbon collection and use the carbon collection make the research and to uh, produce the methanol or the ammonia like this. So I think the carbon capture is very important in the future. Okay, this is the engine. And the next time is fuel cells. The fuel cells, the energy storage produced. So the fuel cells as a lithium battery, but this is now the correctly to use that. It's a high safety, low cost, and long lifespan, and it has the high energy density, but not percent because use the battery sometimes will be make the bomb, make explosion like a fire like this. So so because this has some weakness, we will use a fuel cell. Fuel cell, but it's high, but not limited, but it cannot size. Why? Because just use the uh, hydrogen, use the hydrogen and oxygen together, make the combustion to use the fuel cell. So only by uh, products is water, and there are no harmful emissions and low vibration noise and no magnetic cause movements. So this is a uh, advantage for the fuel cell for there. So for this, we include two parts: is the inland vehicles technical plan and ocean going vehicles technical plan. So sometimes we just use the series hybrid system and parallel hybrid system. But this is a little difference. We combine the fuel cell and engine together, but the engine can be used maybe can be used the methanol or the uh, ammonia, but the fuel cells can be used the methanol because we can use the methanol reformer to produce the hydrogen and put in the hydrogen to the fuel cell for the complex combustion in the fuel cells to uh, give the give the vessels power. So we just have two parts is the PTO or PTI. What is the PTO? What is the PTI? What PTO is the generator absorbs the engine from the main engine to generates the electricity, and the PTI is just absorbing the energy from the power station to drive the propeller. So I think one is just use the engine, give the engine to use electricity. Another one is electromotor model. Just is a motor. The motor gives the power, give the power to the engine, to the wheels, like the wheels moving like this. So this is the difference of the PTO and the PTI. So the third one is conclusions. Conclusions. So we just prospects for the new power types in the future from the 2020 years to uh, 2050 years. So the first, I think the ocean-going hybrids, the power system like uh, combining internal combustion engine, battery solar engine, and wind engine, and the nuclear engine, intelligent, intelligence power system like this. So this is a line. This is a high line for the research. But from the 2030 years to after 2050 years, it's just the SOFC and the intelligence power system like this to make the research. So from this, because we just in this step, so low speed dual fuel energy has the high research point for the researching, and after this is ammonia, hydrogen fuel low speed engine, like the low speed engine can be made to research. This is for ocean going vehicles. And the inland river vehicles is includes like the battery, hydrogen, fuel cell like this because this has a high uh, thermal efficiency. So the thermal engine, battery, hy hydrogen fuel cells can give the vehicles the high thermal efficiency. Can. And per electric system, just use electric and ammonia, hydrogen fuel cell system can be made research from the 2030 and to after 2050 years. Okay, and in the last is a natural gas engine and biomass fuel engine and the methanol like this hydrogen fuel engine can be made research in the future. So we have to make the summary and just for the in future, what is the important for this time is just a low speed dual fuel engine or the low speed engine is the high point research has a high research point for this in the future, and the fuel maybe the methanol, ammonia, maybe has the best research points in the future can be researched. So why hydrogen? Hydrogen maybe in the maybe after 2050 years can be make the good research. I think okay. Okay, this is a summary. So the trend of the fuel diversification or the diversified carbon reduction path is by 2050 years, and maybe the methanol, ammonia, and the hydrogen. So this is has a step, has a maybe follow the year step. We have the focus on which part. So in this time, we can to focus on the methanol or the and ammonia research. And after 2040 years, we can to make the research for the hydrogen. Okay. So the combustion energy remain, I think, is best operation for next 20 to 30 years has no problem. So I think the important is for the ocean going vehicles is just a low speed engine for the research. Okay, thank you very much. Okay, thank you. Hello. Hello, my presentation is finished. Thank you.
Thank you so much, sir, for sharing your valuable insights through such an effective session. If anyone have any query or doubt, then he or she will be free to ask.
If any participant have any kind of question, he or she may ask, please. All are unmuted.
Thank you, Dr. Zhu, for the presentation.
Okay, Mander, thank you very much.
Thank you so much. It was a very good presentation.
Oh, thank you, thank you, thank you.
Yeah.
Dr. Ju, good evening. Sir, I want to ask one question about the use of two-stroke diesel engine in marine industry. Is there any use right now, or we are not using two-stroke engines?
I'm sorry, you can to make the sound loud. I can't hear you, actually.
Good evening, sir.
Hello, hello, hello. Good evening.
Sir, am I audible? Sir, am I
Mander,
audible?
can you translate for me?
Yes, sir. Your voice is audible only. You can proceed.
Sir, I want to ask about the recent scenario of two-stroke diesel engine in marine industry. Is there any
I make
scope?
the research about the GDR engine.
Okay, okay.
Yeah, Dr. Zhu, he is asking that what is the future scope for two-stroke diesel engine in marine for the ships?
For the ships?
Yeah,
Now?
two-stroke. Yes, right now and the future for the two-stroke diesel engine for the ships. Is there any future for the two-stroke engines?
Two-stroke? No, not a two-stroke engine. Maybe uh, in the future, I think two-stroke engine not impossible, I think. But I make the research about the four stroke engine for the DDR engine. But the fields not for the DDR, it's just for the engine and the manual.
So you mean to say that in the future, the two-stroke engine does not have any significance?
Yeah. I think.
So, very good evening. This is INR.
Yeah, good evening.
Very nice session. So my question is, how does the hydrogen fuel is feasible for the long distance shipping?
Manar, where are you?
Yeah, I'm here. So he's asking if what is the scope of hydrogen fuel
For long distance shipping.
for like long distance shipping?
Which one? This one? Wait a moment. This one?
Yeah. So
Yeah,
he's
yes.
asking like how can we use the hydrogen fuel for the long
How
distance
to?
shipping?
This is a problem. This is a good question. Good question. So
Yes.
that why now is not the hydrogen is not for the focus on the research point because the hydrogen storage is a problem. So maybe sometimes uh, now I can just don't use the I don't know if you know the reformer is a marginal reformer or the anomia reformer. I think is best for the hydrogen is production. The hydrogen production maybe is best. So in the future, I can use the marginal reformer connect with the diesel or the fuel cell together used in the vessels. I think this is the best research points. But why to use this? Because this is hydrogen storage is a problem. It's a big problem. Uh, so this is a weakness for the hydrogen. I think.
Okay, I see. I see.
Okay.
So do you have any more questions? Do we have any more questions from the participants? Okay, I think Dr. Zhu, we don't have any more questions.
Okay. Thank you very much.
Yeah, thank you so much, Dr. Zhu.
Okay. Thank you.
Yeah, thank you. Dr. Gitesh?
Yes, sir. Yes, sir. Yes,
Yes,
please.
sir. Yes, sir. Sir, he has finished his presentation.
Yeah, thank you so
Okay.
much,
So
sir.
I
Thank you so
can.
much.
Okay. I can quit now.
Yes, yes.
Yeah,
Okay.
yeah.
Thank
Yeah.
you.
Thank you so
Thank
much.
you so
Thank
much.
you.
Thank you so much.
Okay. Thank you.